Alrighty, friends, let's figure these problems out. So we got to perform the indicated operation. I see an addition symbol there. So when I'm adding or subtracting fractions, I want a common denominator. So I think my first move is going to be to look at the first denominator and factor that. So I need things that multiply to 15x squared and add to negative 8. So I've got like 1 and 15. I don't think that works. 3 and 5. Oh, 3 and 5 if I make them both negative. So negative 3x, negative 5x. So that's going to be x squared minus 3x minus 5x plus 15. Take out the greatest common factor of the first two, which is an x. Let's just write down x minus 3. To get from negative 3 to 15, I got to put a negative 5. Discount, double check that that works. Negative 5 times x is negative 5x, so we're good. You got to woo, because those are the same. So then you get x minus 5 and x minus 3. Now let's look at the second set. I'm going to write that as x squared plus 0x minus 25. So I need things that multiply to negative 25x squared, because that's the first and the last, and add to nothing. Well, wouldn't that be like 5 and negative 5? So we have x squared plus 5x minus 5x minus 25. Take out the greatest common factor. We have x plus 5. Let's put an x plus 5 to get from 5 to negative 25. I put a negative 5. Discount, double check. Those work. So I get x plus, oh, I forgot to woo! X plus 5, x minus 5. All right, now I just took up all of the paper to do that, which is fine. Ooh, notice over there I have x squared minus 25. So I can right away write that as x minus 5 and x plus 5. While I'm here and while I'm factoring, I'm going to factor that other piece that I see over there on the right. So I have x squared minus 6x plus 5. So we should be seeing a bunch of work from you on these. I need to multiply to 5x squared, add to negative 6x. So like 5 and 1 makes 6, but I need negative 6, so let's make them both negative. So x squared minus 5x minus 1x plus 5. Take out the greatest common factor, you get x minus 5. Let's put an x minus 5. To get from negative 5 to 5, I better multiply by negative 1. Discount, double check, it works. Got a woo, woo! I got x minus 5, x minus 1. So that's 4 over x minus 5, x minus 1. And I'm going to pause and erase all the stuff I don't need. I'm going to rewrite, actually I'll talk as I do that. I'm going to rewrite the left side as x minus 2 over x minus 5, x minus 3. And then I'm going to rewrite the right side, because I know I can factor that x squared minus 25 into x minus 5, x plus 5, or x plus 5, x minus 5, whatever we want to do there. And so we will rewrite that as x minus 5, x plus 5. Now I need to analyze the denominators. Oh, I missed them there. Okay, so I have x over x minus 5, x plus 5. I'm seeing that they both have an x minus 5, so that's good. And since I'm adding, I want a common denominator. This one has an x minus 3, so this needs an x minus 3. But if we put it there, we better put it there. And then this one has an x plus 5, so I better put an x plus 5 on both pieces. And I did not plan well for space, but that's what we're going to have. So now we're going to have on the bottom, oh, maybe I don't want to write it there. Move it up a little bit. On the bottom, we're going to have an x minus 5, because that's in both of these. We're going to have an x minus 3, because that's in both of these. And we're going to have an x plus 5, because that's in both. Now, if I could have reduced, if this was like an x minus 3, if I could have reduced, then I wouldn't have needed to include that x minus 3. Now I got to double distribute, so x squared plus 5x minus 2x minus 10, and then single distribute, x squared minus 3x. Whew, there's a lot going on there. So now I just finish by combining like terms. Leave the denominator. We got the x minus 5, x minus 3, x plus 5. We have an x squared and an x squared, so that's 2x squared. 5 minus 2 is 3, minus 3 is 0. Ooh, so that all goes away, and then minus 10. Now, in this case, we are done, because there's nothing more we can do. We could try to factor that top piece, but it's not going to factor into anything nice. So we are all done with that problem. All right, there's a lot there. Quick recap. We're adding fractions, so we got a common denominator. We got that common denominator by factoring the bottoms, so I went ahead and factored. Notice all the work I have on the page right now. You should have work showing up all over the place here. If you're not doing that, then you're doing something wrong. You're welcome to do that work on a piece of paper and then take a picture so that we can see it. That is fine. But you need to, sorry, I was trying to move stuff and it was being weird, but you need to show work. If like just magic answers are showing up, we don't know what's going on. All right, now I look at this next one. This is now an equation. Notice how I have an x minus 5 and an x minus 5? Let's go ahead and multiply both sides by x minus 5. That's a move I can make. I've known that with equations. I can do the same thing to both sides. What I can now do is I can reduce that to 1 and reduce that to 1. So that means I'm going to have 4 over x minus 1 and 1 over x plus 5. So that's much less scary. Now I still am nervous about these denominators. So I'm going to multiply this one by x minus 1 so I can reduce that. But if I do that there, I better do that over here. And then same idea, I'm going to multiply by x plus 5 so I can reduce that, but I better put that here also. Now I'm going to distribute 4x plus 20, 1x, I don't have to actually write that part, but that's fine, minus 1. Oh, now this is just a linear equation. So I'm going to subtract x from both sides. I'm going to subtract 20 from both sides. And then I'm going to divide by 3. Notice, I should have noted right here, x cannot be 5, negative 1, and negative 5. X cannot be any of those values. I should have noted it on the other one also. This is a 7, so we're okay. We didn't hit something that was not possible. All right, now we got some words. So let's go ahead and read. We've got Eric and Daniel. I couldn't see the E, so I didn't know what was going on. Eric and Daniel are graphic designers. Eric charges a setup fee of $50, so we're going to have to pay $50 plus 8 per page. Daniel charges $100, unlimited pages. Let X represent the number of pages. The amount Daniel charges per page is 100 over X. Write an expression that represents how much Eric charges per page. Well, so my first move is going to figure out what's the total cost and then divide by number of pages. So the total cost for Daniel is going to be the $50 he's charging plus the $8 for every page, and the pages is X. So for 8, that's the total cost. I have to pay $50 no matter what. For every page, I must pay $8. And then I got to divide that by X, because that's giving me the average cost, or how much we are charged per page. If you think about units, the top piece will give me your total cost, so that's money, and then the bottom will give me pages, so it's cost per page. Write and solve an equation to determine the number of pages for which Eric and Daniel charge the same price. So that means we're going to have 100 over X equals 50 plus 8X over X. Now that looks a little scary, but notice, first off, X can't be 0. But notice that X is on both sides on the denominator. So let's go ahead and multiply by X, and we can reduce both sides to 1. So then we're just given 100 equals 50 plus 8x. Not 80, silly. 8x. Subtract 50 from both sides. You'll have 8x equals 50. And divide by 8. And 50 over 8, that's not a integer, but we can handle that. So 50 divided by 8 is going to be 6 1/4. All right, interpret the solution. Well, let's see. When will the amount Eric charges be lower? Well, let's check. If x equals 6, Eric charges 50 plus 8 times 6. So that's 98. And Daniel charges 100. Regardless, charges 100. If x equals bigger than 6, I'm going to pick 10 just because that's a nice number. Eric charges 50 plus 8 times 10, which is 100. And then Daniel charges 100. So here's my argument. If I need 6 pages or fewer, then I'm going to go with Eric. If I need more than 6 pages, I'm going to go with Daniel, because Daniel is a better cost for me if I'm buying more than 6 pages. This is obviously an example with pages. Since it says graphic designers, that first made me think of like t-shirts, because there are various businesses nearby that do like screen printing for t-shirts or signs or things like that. And so you want to figure out, okay, what's the best option for me based on how many t-shirts or whatever I'm buying. So make sure for number 5 there, make sure you explain that. I didn't write that all down, but my argument again would be, if I'm getting 6 pages or fewer, I'm going with Eric because I pay less than $100. If I get more than 6 pages, then I'm going with Daniel because my cost will be lower.